Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, in this lecture, we are going to discuss about the projections of the solids which will be obtained on the auxiliary vertical plane as well as the auxiliary inclined plane. So we are going to evaluate how the projections of a solids can be obtained on AVP which will be inclined with respect to vertical plane at a certain angle, and similarly we are going to work out the auxiliary projections of the solid which will be prepared on the auxiliary inclined plane which will be inclined with respect to HP at a given angle. So let us read out the statement. So the statement reads as: a given cube has an edge 45 millimeter. It is lying with one of its faces on the horizontal plane. You can see it is lying with one of its facing on the horizontal plane with the edge inclined at an angle of 30 degree to the VP. We can check over here. This edge of the cube is inclined with respect to the vertical plane at an angle of 30 degree. So first of all, we are going to draw its projections. Now this solid whose edge is inclined with respect to the horizontal plane at an angle of 30 degree. Now this will be viewed by an observer which will be looking at this particular object or the inclined solid through the AVP which will be making an angle of 50 degree to the vertical plane. So we are going to draw the auxiliary elevation on the AVP which will be inclined at an angle of 50 degree to the vertical plane. Then in the second stage, we are going to draw the auxiliary plan of this solid, inclined solid, on the auxiliary inclined plane which will be making an angle of 35 degree with the horizontal plane. So both of these two cases we are going to evaluate. Now first of all, we are going to draw the projections of this cube assuming that the edge of the cube happens to be perpendicular to the vertical plane. Then in the second stage, we will be inclining this edge at an angle of 30 degree to the VP. Thereafter, we are going to work upon the auxiliary elevation of this inclined solid on AVP and auxiliary plan of this solid, inclined solid, on the AIP. So let us start working out the problem. Now here you see, first of all, as I told you, that we are going to evaluate the projections of the solid assuming that the edge of the solid happens to be perpendicular to the vertical plane. So the top view of this cube will appear to be a square over here. So these are the bottom part projection, that is bottom face projection, that is A, B, C, D, and similarly the top face projections will be 1, 2, 3, 4. So the edge of this particular cube has been given to be 45 millimeter. So having drawn this top view of this cube, after assuming that the edge happens to be perpendicular to the vertical plane, so we have drawn the top view of this particular cube. Now let us draw the front view. So as I told you that A, B, C, D, they are the points which are lying onto the base. So on the base, once we are looking from the front, so A dash, D dash will be the projections of the base in the front view. Similarly, B dash, C dash, they are the projections of the base which are obtained in the front view on the horizontal plane, that is onto the XY line. Similarly, for the top face, once we are looking from the front, 1 dash, 4 dash are the projectors which are obtained corresponding to the top face of this cube. Similarly, once we are looking from the front, so 2 dash and 3 dash, they happen to be the projectors of this top view edge over here, right? So once we draw it from the front side, so whatever the top face was there, its projectors, they are obtained onto the vertical plane. So this is also the true shape in the front view, true shape of the cube, because one face is also parallel to the vertical plane. Similarly, the top view also provides us with the true shape. So only one marking we have done, because all the edges of the cube, they are equal to 45 millimeter. Now we are provided with the information that one of the edge of this cube is inclined at an angle of 30 degree to the vertical plane. So this is an inclined cube whose projections on AVP and AIP are to be obtained. So first of all, let us obtain the projections of the inclined cube. So please check. We are going to incline this cube such that one of the edges will be inclined at an angle of 30 degree. Please see, this is the edge which is inclined at an angle of 30 degree over here. So since the edge, that is CD, so CD edge of the base of the cube, we are assuming it to be inclined at an angle of 30 degree to the vertical plane. Now the observer is going, we have shifted this particular projections in view number 3. Now observer is going to look at this particular solid from this end. So as the observer is going to look at this solid from this end, so now the front view corresponding projections will be evaluated. So we are going to draw the horizontal projectors through 2 dash, 3 dash, 1 dash, 4 dash, and similarly horizontal projector through B dash, C dash, A dash, D dash will be lying on the HP. And the vertical projectors through all these points we are going to draw, and let us work out the corresponding points over there. So please see, the corresponding points will be that this is the point C. So this point will be C dash over here, right? Similarly, this is the point B. So B dash will be appearing over here. This is your point D. So D dash point will be appearing at this position on the base. And finally, your A dash point will be appearing at the bottom over here. Similarly, because 1, 2, 3, 4, they were the points of the top face. So this is the point 3. So horizontal projector through this 1, 2, 3, 4, they are all lying over here. 1 dash, 2 dash, 3 dash and 4 dash, they are lying over here. So the projector through 1, so you see the vertical projector through 1 and the horizontal projector through 1 dash will give us projection of 1 dash point. Similarly, the projector of 2 vertically it is taken, and horizontal projector through 2 dash, so we get the projection 2 dash point over here. Similarly, this is the point 3, so vertical projector through 3 and horizontal projector through 3 dash gives us the point 3 dash. And finally, vertical projector through point 4 and the horizontal projector through point 4 dash will give us 4 dash. Now we have to join all these edges over there. Now since the observer is looking at the solid from this orientation, so which is the farthest point from the observer? 3C edge, the vertical edge of this cube, which is 3C. So this will be dotted. So any points which will be joining with 3 and C, they have to be drawn dotted, unless these points, these edges, these lines, they will be falling onto the boundary. If some edges they are falling onto the boundary, so these edges will be drawn dark. Otherwise, those edges which are not covering the boundary, they will be drawn dotted. So this is the edge which is on the back side. So 3C edge is lying on the back side. So that is why 3 dash, C dash has been drawn dotted. Whereas the edge 2 dash, 3 dash and the edge 3 dash, 4 dash, they are part of the boundary. So there are 2 more edges which are joined with 3 dash, that is 2 dash, 3 dash over here. So you see there is severe inclination over here. That is, even though this is going to be dotted, but this is part of the boundary, so you cannot draw it dotted. The boundary has to be dark. Similarly, 3, 4, this edge, again this is part of the boundary. So the 3 dash, 4 dash edge which is visible in the front view will be drawn to be dark. Similarly, B dash, C dash, again it is part of the boundary, so it won't be drawn dotted. And similarly, C dash, D dash will also be drawn dark. So these are the projections of the inclined solid in which the one of the edges of the solid, it is inclined with respect to the vertical plane at an angle of 30 degree. Now with these inclined solid projections, now we have to draw the auxiliary elevation on AVP making an angle of 50 degree to the vertical plane. That is, if the solid is assumed to be inclined, now this inclined solid is being viewed by an observer which is looking at the solid at an angle of 50 degree with respect to the vertical plane. So how the projections of the solid, that is the auxiliary elevation projections of the solid, will be obtained onto the AVP which is oriented at an angle of 50 degree. Similarly, we are also required to draw the auxiliary plan of this solid, inclined solid, on AIP, and this AIP will be assumed to be inclined at an angle of 35 degree to the horizontal plane. So onto this plane, auxiliary plan projections we need to work out. So let us work them out one by one. So first of all, we are going to work out the projections as auxiliary elevation on the AVP which is making an angle of 50 degree to the VP. So the inclined solid projections as we have discussed, so they will be drawn once again. So just see, this we have already discussed how we have obtained these front view and the top view of the inclined solid. Now this is the inclined solid projections which are available with us. Now this solid is being viewed by an observer at an angle of 50 degree to the vertical plane. So there will be an AVP which will be drawn. Just see x1, y1. So x1, y1 is an AVP onto which auxiliary elevations are to be evaluated. So over here, once again you see we have these 4 points. So these are 4 points corresponding to the base and 4 points corresponding to the top face of this particular solid. Now from these 4 points, the perpendicular projectors will be drawn onto the AVP. Just see, we have drawn the perpendicular projectors on the AVP, and having drawn these perpendicular projectors, which distances we are required to draw on the AVP? On the AVP, the view which will be drawn will always be the auxiliary elevation. So since auxiliary elevation is to be drawn on AVP, so the distance of, you see, A dash, B dash, C dash, D dash, and distance of 1 dash, 2 dash, 3 dash, 4 dash will be projected on the corresponding projector lines for these points. So let us start working out the projections over here for the auxiliary elevation. So we have drawn an AVP at an angle of 50 degree with respect to the XY line, that is with respect to the vertical plane. Now let us start drawing the projection. So please see, this is the coordinate point for point A of the base. So I am going to project it. And what is the distance of A dash from the horizontal plane? 0, because ABCD surface is lying on the horizontal plane. This is the base of the cube. So this is the base of the inclined cube. So A dash is lying at a 0 distance from the XY line. So here I will be writing down A1 dash at the X1, Y1. Similarly B. So I project this B. What is the distance of B dash from XY line? 0. So B dash will be projected here. This is my coordinate location for projector line for C. So what is the distance of C dash from XY line? Again it is 0. So C dash with C1 dash will be located over here. This is my projector line corresponding to the point D of the base. So what is the distance of D dash from the XY line? 0. It is resting onto the horizontal plane. So D dash is also located over here. Now let us work out the distances of 1 dash, 2 dash, 3 dash and 4 dash. So 1 dash. So please see, 1 dash is at a distance of 45 millimeter above the horizontal plane. So from the locus of 1, this is my X1, Y1 line. I'll measure the distance of 45 millimeter and draw a point, and this point's name will be 1 dash. Similarly, point 2, this is the top face. So 2 dash distance from XY is again 45. So measure 45 millimeter from here. For 3, again the distance is 45 millimeter. So measure the point 1 dash at a distance of 45 millimeter from X1, Y1. And finally the point 1 dash will also be located at a distance of 45 millimeter. Now we need to work out which one of these edges. So boundary has to be dark. So boundary will be dark. Which one of these edges will be drawn dotted? You see, the observer is going to view this object from this end perpendicular to x1 y1. Observer is going to look at this object. Now which one is the farthest edge from the observer? A1. So A1 is the farthest edge. So the edge 1 1 dash and A1 dash will be drawn dotted. Rest everything will be drawn dark over here. And as again A1 dash and B1 dash is again falling in boundary, A1 dash and D1 dash is also falling in boundary. So this will not be drawn dotted. Similarly 1 1 dash and 2 1 dash, it is again falling in boundary, and 1 1 dash and 4 1 dash is again falling in boundary. So this will also be drawn dark. So only the edge A1 dash and 1 1 dash will be drawn dotted. Rest everything has to be drawn dark over here using the object line and the HB pencil. So the name of this view is auxiliary elevation, since we have plotted the distance of elevation over here to obtain this auxiliary view. So this is all about the first part. Now let us pick up the second part of this problem. So here once again we have the inclined solid. So the projections of the inclined solid we have picked up from the previous discussion. Now we have to draw AIP. So AIP will be inclined with respect to horizontal plane and it will be perpendicular to the vertical plane. And the angle of inclination of this plane x2 y2 is 35 degree. So please see, this is an AIP which is inclined. So this is the second iteration. That is why we are saying that this is x2 y2. Now there are 4 points corresponding to the top face. There are 4 points corresponding to the bottom face. So total 8 points are there for this particular inclined cube. So observer is going to look from this end. Please see. So corresponding to these 4 points and corresponding to these 4 points, 8 projector lines will be drawn perpendicular to the x2 y2. So 8 perpendicular projector lines, they have been drawn perpendicular to x2 y2, which is the AIP, and this AIP has been drawn at an angle of 35 degree with respect to the horizontal plane. Now which distances will be drawn? The projections obtained on AIP, they are called auxiliary plan. So the distances of the plan will be required to be projected over here. So we'll be picking up these points one by one. So please see, projection, the distance of points A and point 1 from the XY reference line, it is this one. So we are going to measure this length using the divider or the compass or the scale. So measure this length and mark this distance. So corresponding to the projectors of A dash and 1 dash. So this distance, please see, distance of XY to this point A or to this point 1 will be marked. So from the projector locus line of A dash, from this point, this distance which was measured over here will be marked corresponding to A dash projector line. Similarly, where is 1 dash? 1 dash lies here. So corresponding to 1 dash, I will be moving here from the x2 y2. The same distance will be marked along the 1 dash projector line. So name of this point will be A2. Name of this point will be 1, 2. Let us work out points 2 and B. Let's move in sequence. So the distance of point 2 and B from XY line is slightly shorter than that was there for A and 1. So we'll measure this distance and plot it on the auxiliary view corresponding to the locus lines of 2 dash and B dash. So for B dash, I'll move to this point. From x2 y2, the same distance will be plotted which was measured over here. Similarly, from corresponding to 2 dash locus line, the same distance will be plotted as it was measured over here below the XY reference line. For point 3, so this is the distance. Once again, this distance will be measured using your compass or the divider, and corresponding to the locus lines of 3 dash and C dash, this distance has been marked over here in front of the x2 y2. And corresponding to the point D, this is my distance of D and 4 point below in front of the XY reference line. So same distance corresponding to points 4 dash and D dash has been measured in front of the vertical plane. So I have plotted all these points. So let us start joining. And while we are joining, you see we are looking from this side. Observer is looking at this object from this side. So the point which is farthest away from the observer and closest to this AIP, that is x2 y2, it is 4 dash. So any point which will be joined by 4 dash, unless it falls in the boundary, has to be drawn dotted. Rest everything will be drawn dark over here. So let us start joining. So these are all the points, and once you start joining, you will find that this is the point 4 2 which is lying behind basically. So since this point or this edge, these edges, these surfaces, you see this surface and this surface. So these three surfaces, they have been covered by surface this and surface this. So the surface A2 B2 C2 D2 and the surface 2 2 3 2 C2 B2 and the surface 1 2 2 2 B2 A2. These three surfaces, they have covered these surfaces which are lying behind this, and corresponding to these three surfaces, these are the three dotted lines which have been obtained. So this way we have been able to obtain auxiliary plan of the inclined solid on the auxiliary inclined plane, which happens to be perpendicular to the vertical plane and it is inclined to the horizontal plane. So this is how you see we can work out the auxiliary projections of any given solid on AIP or the AVP, which is inclined with respect to the reference plane at certain inclinations over there. So this is all about the discussion of projections of the solid for today. So thank you very much. Thanks a lot.